सुन लीजिए। सुन लीजिए। गुड इवनिंग, गुड इवनिंग, गुड इवनिंग। जल्दी से चैट में सब लोग बता दो एक बार कि सब कुछ दिख रहा है नहीं दिख रहा है। मेरी ऑडियो क्लियर है नहीं है, मेरी जो स्क्रीन शेयर है वो दिख रही है नहीं दिख रही है, जल्दी से बता दो सब लोग, जल्दी से। The video is lagging, Aditi, is it? Can you just try and refresh the page? Just try and refresh the page, Aditi, and let me know if it works or not. गुड इवनिंग गुड इवनिंग जल्दी से चैट में सब लोग बता दो एक बार कि सब कुछ दिख रहा है नहीं दिख रहा है ओके the voice is not clear. Hold on. Yeah, Tarishi, try to refresh the video once. Let me know if it's clear or not. Okay, Abhishek, thank you. Uh, Rajveer, you as well. Just refresh the page, please. You too, Arun. If the video is lagging, guys, just refresh the page. Okay, I'll moderate the one who's moderating. Please check it once. Everyone is complaining about the lagging issue. Please check it once. Okay, okay. So let's start today's discussion, today's topic, today's session, whatever you want to call it, because what we are going to discuss today is geometry, and it is if you were to divide the entire mathematics and the quant section into three different parts. That is, one is you'll have your arithmetic, then you'll have your algebra, and then you'll have your geometry. Geometry is the easiest topic of them all. Geometry is the easiest topic of them all. And why am I saying so? Because in number systems, there in most of the topics of in most of the topics of arithmetic, there are no formulas. You just have to play with the concept, and that can be a little difficult sometimes if the concept is not clear to us. That can be a little difficult sometimes, because and also for any particular questions, there's no fixed number of steps or fixed step that you can follow to get to the answer. You'll have to uh, twist all the concepts that you know to get the answer, right? And in algebra as well, what the problem is, there are some formulas, there are some formulas, but what happens is there are some formulas, but what happens is that most of the times you won't be able to use those formulas in all the questions that you get. You won't be able to use those formulas in all the questions that you get, right? But in geometry, if you are able to visualize what the question says, if you're able to visualize what the question says, your question is 90% solved. That's it. You just have to visualize the question. Your question is 90% solved, right? Why am I saying so? Because we just have to remember a little bit of some formulas, very minimal number of formulas. That's it. And the second you're able to visualize what the question is asked, your 90% of the question is solved right then and there. Okay. So what we are going to do today is that we will be taking one question at a time. Okay, is it still lagging? Abhishek, Ramya, Aditi. Uh, 1 second, I'll just check with the moderator. 1 sec. Okay, coming back, coming back to the discussion that we were having. So, what we are gonna do today is we will take some previous year questions. We'll take some previous year questions and we'll see uh, how those could be solved. What are the easier ways that could be solved? How a person or a student who's above average or average would have solved the question, and how someone who's the topper must have solved it. Okay, Varsha. Okay, is it lagging still? I'd ask the moderator. 1 second. Okay, let's come back to the discussion again. Yeah. So what we're going to do today is that we will be taking some previous year questions. We'll see how different people who would have had different percentiles would have solved it. What I mean by this is we'll see what how an average student must have solved it, how an above average student must have solved it, and how someone who's the topper must have solved it. So this is what we're going to discuss today. So, and also keeping this in mind, we'll take every question one by one and we'll see what can be done, what can't be done. Okay. So, and also for every question, we'll also be discussing some concepts. We'll also be doing some concepts with which these can be solved. So let's take the first question for now. Let's take the first question for now. What does the question, 1 second. Yeah. So this is the question. Yeah, this is your question. What does the question say? It says that let ABCD be a parallelogram such that the coordinate of three of its vertices ABC are 1 comma 1, 3 comma 4 and minus 2 comma 8 respectively. Then the coordinates of the vertex D are what? I'll give you 45 seconds. That's it. I'll give you 45 seconds because this is a question that can be done in 10 seconds. A topper will do it in 10 seconds. Okay. So let's now do it. Sorry, I'll give you 45 seconds. I want you to tell the answer in the chat. I'll give you 45 seconds. Go on. Okay. Okay. So let's now try to solve this. Now, first, let's just visualize this. What did I say in the starting? Any question that you're able to visualize, you've solved it 90%. Let's try and visualize it. What have they given us? They've given us a parallelogram. They've given us a parallelogram, right? This is how what a parallelogram looks like. ठीक. अब इसके coordinates एक के 1,1 दिए हैं. Now then you have 3,4 and then you have minus 2,8. And let's consider this coordinate that you have to find out to be x1 comma y1. Okay, the coordinates of this vertex are x1 comma y1. Okay, now there are a lot of ways to solve this. Now, how would a person who's an average student solve it? What they do is, first they would take out the midpoint of this diagonal. This is a diagonal, right? This from point 1 comma 1 to minus 2 comma 8. This is a diagonal of a parallelogram, right? So they'll take out the midpoint of this. How will you take out the midpoint? You'll do 1 plus minus 2 1 plus minus 2 upon 2 comma, then what you do 1 plus 8 by 2. Now this will be equal to what? This will be equal to minus 1 by 2 comma 9 by 2, right? So this is the midpoint of this diagonal. And if I were to draw the second diagonal as well, that would also pass through this midpoint, right? And this would be the midpoint of this diagonal as well. So since I have the coordinates of this point, I can easily take out the coordinates of this point as well. How can I take it out? I'll use the same formula of midpoints. What I can say is minus 1 by 2 is equal to what? It is equal to x1 plus 3 by 2, and also 9 by 2 is equal to what? 9 by 2 is equal to y1 plus 4 by 2. So you will get the values of x1 and y1. What is x1 from here? x1 is equal to minus 4. And what is y1 equal to? y1 is equal to 5. So is that an answer in the options? Yes, it is there. So this is your answer. But this took a lot of time, right? Didn't it? It took a lot of time. Now, what would an above average student do? They'd say that I know that the opposite sides of a parallelogram are always parallel. The opposite sides of a parallelogram are always parallel. So for two parallel sides, what is the condition? That their slopes must be equal, right? So the slope of this line will be equal to the slope of this line. So I can take out the slope of this line. How can I take it out? I would do y1 minus y2, that is 4 minus 8 upon 3 minus of minus 2. What do I get? I get minus 4 upon 1, which gives me minus 4. Now this slope must be equal to the slope of this line as well. One second, I'll just bifurcate it. Yeah. So the slope of this line will be equal to the slope of this line. What is the slope of this line? Minus 4. I already took it out, right? So the slope of this line is what? 1 minus y1 upon 1 minus x1 equals to minus 4. So I'll get a equation in x1 and y1 from here. I'll get an equation in x1 and y1 from here, and again I'll say that this line is also parallel to this line. So their slopes will be equal as well. So I'll get an equation in x1 and y1 similarly from here as well. I'll solve these two equations and I'll get x1 and y1. But it took what? About 1.5 minutes of my time. I said that the question can be done in 10 seconds. Now a topper would know that. A topper would know that. And what would a topper do? They'll simply they'll say that I know that these opposite sides are always equal. The opposite sides are always equal. So when I take just the abscissa of this point and the abscissa of this point, I'm seeing that the abscissa goes from 3 to minus 2. So there's a loss of minus 5. So there's a loss of minus 5, right? And also the ordinate from this point to this point, it lost 4 points. It lost 4 points. Since this length is equal to this length, this abscissa and ordinate must also lose the same amount of points, right? So 1 would lose 5 more points. What would that give me? 1 would lose 5 more points. So 1 minus 5 is minus 4, and 1 minus 1 minus 4, ordinate will lose 4 points. 1 minus 4 is what? 1 plus 4 is what? 1 plus 4 is what? It is 5. So this is my answer. It was a 10-second question this way, right? Is this clear, everyone? Let me know in the chat. So this is the simplest way that you can solve this question, right? What did I do? I did nothing. I just saw what was the loss or gain in the abscissa and the ordinate of one side, and I did the same thing on the other side since I knew the lengths were same, right? Quickly tell me in the chat if that was clear or not. Then we'll move to the next question. Okay, understood. Now this is another previous year question. Again, the second you visualize it, the question will be 90% solved. Try and do this. Try and do this. I'll give you 30 seconds. I'll give you 30 seconds. Okay. Now let's try and solve this. Okay. Let's try and solve this now. What does the question say? The question says that a trapezium ABCD has AD side parallel to BC. So there's a trapezium where, and what is a trapezium? A quadrilateral where one set of opposite sides are parallel, not equal, nothing about equality or anything. Just that one set of opposite sides are parallel. Okay. Now, angle BAD is 90 degree, BC is 3 centimeters, AD is 8 centimeters. Okay. If the perimeter of the trapezium is 36 centimeters, then the area in square meters is what? Let's try and draw this. What is it trying to say? I have a trapezium of this sort. This is what this trapezium looks like. Okay. So I have, which angle is 90 degree? BAD. Suppose this is my A. Okay. So A, B, C and D. So this is my trapezium. Okay. This is my trapezium. The side BC is 3 centimeters. This is 3 centimeters. This is 8 centimeters. So what did we do wrong over here? It is that the upper side is the larger one. The upper side is the larger one. Which is the larger one? This AD is the larger one. And what is BC equals to? It is, since it is 3, it is smaller than the other one. So this is my D. This is my C. This is my B. So this is 90. This side is 3 centimeters. This entire thing is 8 centimeters. And the trapezium's perimeter is 36. The trapezium's perimeter is 36. Now, I know that if I were to draw this little thing over here, if I were to draw this altitude over here, I would easily be able to find out this thing, the area that I have to find out. What is the area of a trapezium? What is the area of a trapezium? Oh, it is still lagging. 1 second, I'll check. 1 second. It is still lagging. Give me 1 second, I'll check. Okay, let's come back. Okay, understood. It's done now. Let's come back. Now, suppose I call this altitude to be h. What can I say about the perimeter now? Since this thing is h, this thing will also be h, because these are equal, right? This is equal. Since this was 90 degree, this is also the altitude of this trapezium, right? This is also the altitude of the trapezium. For area of the trapezium, I need half into the sum of parallel sides, the sum of the lengths of the parallel sides, right, into the distance between them, that is h, right, into distance, that is h. Now, since I took this to be h, and this thing is BC is 3 centimeters, and let's say I name this point as E. What is the length of AE? Is it not 3 centimeters? Right? It is also 3 centimeters. And what is the length of ED? It is 5 centimeters. 8 minus 3. And what will the length of this be? This be CD. What will the length of CD be? How can I take that out? Very easily. I can say, I see that the perimeter of this entire thing is 36 centimeters. So 36 is equal to what? It is 8 plus 3 plus h plus dc, right? What do I get? 8 plus 3 is 11. I can take that over there and I get 25 is equals to h plus dc, right? 25 is equal to h plus dc. I can also say that this h5 and dc, I'm writing it over here, okay? h5 and dc, what do they form? They form a Pythagorean triplet. What is a Pythagorean triplet? All the numbers that follow this property, a square plus b square equals a square plus b square equals c square. For example, one set of numbers is 2, 3 and 5. So these are Pythagorean triplets. Why? Because 2 square, let's say this is a, b and c, right? So a square means 4 plus B square is what? 9, right? Is equal, sorry, this was, sorry, 2 and root 15. So this is a Pythagorean triplet. What is, sorry, root 13? What is root 13 square? It is 13. So these three are Pythagorean triplets. One thing we know about Pythagorean triplets. Another Pythagorean triplet is what? It is 8, 6 and 10. 8, 6 and 10 are also Pythagorean triplets. Now, how can I say that? What is 8 square? It is 64, plus what is 6 square? It is 36, equals to 100, right? Which is equals to c square. So 8, 6 and 10 are also Pythagorean triplets. Now, I can say that H5 and DC are Pythagorean triplets. What? So can I not find out all the Pythagorean triplets that have the number 5 in it? That have the number 5 in it. I can say one of those Pythagorean triplets is 12, 13 and 5. Because why? 12 square is 144 and 5 square is 25. So 144 plus 25 is 169, which is equal to c square, that is 13 square. And also I had to check this thing, that 25 equals h plus dc. H plus dc, is it 25 or not? Is it 25 or not? What have I taken DC as? It is 13 and H is 12. Now 12 plus 13, is it 25? Yes, it is. So this is what numbers I'll have to take. I already had the 5. What is H now? H is 12. H is 12 and this thing is 13. I only needed H. I didn't care about 13. I only needed H because I know what the sum of the parallel sides is. I'll write it again, okay? I have half into, what is the sum of parallel sides? Over here, 3 plus 8, which is what? 11 into, what did I take out this to be? H, 12. Now, what is this equals to? This is equals to, uh, yeah, where was I? Yeah, this is equals to what? This can cancel each other and centimeters square. So this is your answer. That's it. What was the trick that we used here? We used this trick, that we should consider Pythagorean triplets. We should consider, since we had this property in our mind, because we had already found this out using the perimeter of the trapezium. I can assume the numbers to be this, and then I can check from here, do they satisfy or not. And since these had to be Pythagorean triplets, since they were sides of a triangle, right? Since they were sides of a triangle, they had to be Pythagorean triplets. And I found out that they satisfied this as well. Thus, I had my numbers. So this was the trick that we used here. It saved about 1.5 minutes of our time. Let me know if there are any doubts. 30 seconds I'll give you. I'll give you 30 seconds. Then we'll move to the next question now. Let me know quickly. Okay, now let's move forward. Let's take the next question. This is also previous year question. Okay, try and solve this. Quite easy one, right? Yeah, try and solve this. This is very easy. This is very easy. The second you draw this diagram, the question is not just 90. This time it's 95% solved. The second you see the diagram in front of your eyes. Anushka, I took 5, 12, and 13 because I had that property. I had already found out that h plus the length of side DC must be 25, right? So I had to find out Pythagorean triplets that had the integer 5 in them. I had to find the Pythagorean triplets that had the integer 5 in them. And luckily, the first Pythagorean triplet that came to my mind was true. And that satisfied the condition of 25 equals h plus DC. And there are not a lot of Pythagorean triplets that have the integer 5 in it. Okay, so that is also of a big help. Not a lot of Pythagorean triplets have the integer 5 in it. Okay. Okay, now let's solve this question. Okay, now let's solve this question. What does the question say? It says that all vertices of a rectangle lie on a circle of radius r. If the perimeter of the rectangle is p, then the area of the rectangle is question mark, and there are options given. So what do I visualize this as? That I have a circle and this is its center, and the rectangle is something like this, and it is such that this diagonal that I draw must pass through the center. Why did I say that the diagonal will pass through the center? Right? I know for rectangles that the opposite sides are equal. The opposite sides are equal in every rectangle. So I have to make sure if this is one of the sides of the rectangle that I take, if this is one of the sides of the rectangle that I take, and let's say it is at a distance of h centimeters from the center. So the other line that I will get that will also be of this length will also be on h side, other h side of the center of the circle, right? So you can't draw a rectangle like this. Suppose this was my circle. Okay, suppose this is my circle and this is my center. You can't draw a rectangle like this. Okay, because since this and this has to be equal, and you will only get equal chords at same distances from the center. That's why your circle will look like this only. And I'll draw the circle again. Okay, I'll draw the circle again. This is your circle, this is your rectangle, and this is your center, and it is symmetrical around the center. Okay, so your diagonal will always pass through the center. Now, what have I been given? I have been given the perimeter of this rectangle is P. Suppose I take this length to be L and breadth to be B. Okay, and this radius is given to be R. So what is this diagonal length? Is it not 2r? Because it is the diameter of the circle, right? It is passing through the center from one point to other. So this length is also given to me, that is 2r. I've been told that 2 into L plus B, that is the formula for the perimeter of rectangle, is P. So L plus B is what? It is P by 2. Okay. Also, I am told that L square plus B square is equals to 4r square. What did I do here? I saw that this was 90 degrees. So this is a right angle triangle. So L square plus B square must be equal to 2r square, which is 4r square, right? And I have to find the area of this rectangle. What will the area of this rectangle be? L into B. I have to find the value of this expression. I don't have to find these values individually. Okay, I have to just find the expression L into B. Now I've been told that L plus B is equals to P by 2. And if I was to square this on both sides, I'll get L square plus B square plus 2LB equals P square by 4. And why did I say that? Why, like, you can ask me that, sir, how will we know that we have to do a whole square of this? And then I'll say that I have to find out this expression L into B. And I see from all the equations that I have right now, I see there is no L into B. But there is a way that I can make L into B from this. And what is that? If I was to square this entire thing, this a plus B whole square is what? A square plus B square plus 2AB So I'll get an expression where both these things are multiplied. That's why I whole squared it. Okay. Now the next thing is I have this L square plus B square, but I only need L into B. And but I know the value of L square plus B square. What is it? It is L square. Sorry, it is 4R square. So I can write 4R square plus 2LB equals P square by 4. Right? Now, what is then from here? What is 2LB? It is P square by 4 minus 4R square. And what is LB equals to? I'll write it here on the other side. What is LB equals to? LB is equals to P square by 8 minus 2R square. Is it in the options? Yes, it is. This is the answer. It's a very easy question. You don't, and what trick did we use here? We saw that we just had to find an expression. We didn't have to find L separately and B separately and multiply them together to find the area. I just had to find the value of this expression, that is L into B, not the individual values, just L into B. So that's why this question became almost a 15-second question, right? So this is how you save time. You read, even if you're taking a lot of time in reading the question, it's all right, because if we read the question clearly, we might find some trick that reduces the answering time into half. So we'll again be saving time in total, right? Go through this. Let me know if there are any doubts. Okay, let's move to the next question now. And your question is this. Your question is this: a regular polygon A and B now have number of sides in the ratio 1:2 and the interior angles in the ratio 3:4. Then the number of sides of B, the polygon B, equals question mark. There are no options for this question, because then what you do, you just try and satisfy the equations. I want you to solve this. Okay, go on. 10 more seconds. I'll give you 10 more seconds. Yes, Raghav, you're right. Kuber, that's not the answer. Aditi, perfect. Okay, let's now solve this question now. Okay, let's try to solve this question now. What does this question say? The regular polygon A and B have number of sides in the ratio 1:2 and the interior angles in the ratio 3:4. Then the number of sides, sorry, of polygon B is what? Number of sides of, once again, I'll just take the pen. Yeah. Um, yeah. So, what do I know about polygons? What do I know about polygons? I know one property about polygons. What is that? That the sum of the interior angles, sum of the interior angles of any polygon is equals to what? It is equals to n minus 2 into 180, right? And what is n? N is the number of sides. Number of sides. This is the formula that I know for polygons. And I also know that a polygon that has n number of sides will have n number of interior angles as well. So these two things I know. These two things I know. Let's say that, let's consider polygon A for a second. Okay, let's consider polygon A for a second. And since these are regular polygons, what does this mean? That all the interior angles will be of the same length, all the sides will be of the same length, and all the interior angles will also be of the same degree, right? Now, let's consider the polygon A. Let's consider polygon A. Can I write that one of its interior angles will be equals to the total number of, sorry, the sum of all the interior angles divided by the total number of angles there are? That is, if it has n sides, it will also have n number of angles also. So the measure of one interior angle is equals to this, right? Measure of one interior angles is this, right? Let's consider that polygon A has n number of sides. If it has n number of sides, then how many sides will polygon B have? Since it is in the ratio 1:2, it will have 2n sides. So if I write something like this for the interior angles of A, what do I have to write for interior angles of B? For interior angles of B, I have to write the total number of sides, that is 2n minus 2 into 180 divided by total number of angles, which is this. And what is given? That the ratio of this is 3:4. That means that if I was to write n minus 2 into 180 upon n upon 2n minus 2 into 180 upon 2n, this would be equals to 3/4. This would be equals to 3/4. And let's solve this a little furthermore. This will cancel with each other and you would be left with n minus 2 upon n minus 1 equals to 3/4. And from here, what you will get? You will get 3n minus 4n, that gives you n, and from here you have 5. So n is equals to 5. What was n? N was the number of sides of A. And what do we have to find? The number of sides of B. Since n is 5, number of sides is 2n, so 2 into 5 gives me what? Nothing but 10. So 10 is my answer. Quite simple. There is no trick involved in this. No trick app whatsoever. But even then, even without using any trick, what you have to remember is just this one formula. Polygons have just one formula, right? And this is it. This was barely a 25-30 second answer. What? Right? So go through this. Let me know if there are any doubts. We'll move to the next question after this. Let me know if there are any doubts. We'll move to the next question after this. Okay, let's move to the next question, and let's take a, since the class is about to be over, let's take a very good question. Let's take something that will engross your brain. Do this. In this, you'll have to visualize. Okay, in this you'll have to visualize and try to solve this, because even For this question, the way you draw this diagram is very important. The way you draw this diagram is very important. Go on, try and solve this. Okay, let's solve this now. Let's try and solve this. So, once again, I'll just take the marker. So, what I said was the way you draw this diagram is very important. The way you draw this diagram is very important. So, but what our natural instinct is that we read one line and we draw the diagram. We read one line and we draw the diagram. Let's do that only. Let's do that only. Okay. So, I have a triangle ABC where AB is equals to AC and which is equals to 8 centimeters. So I have an isosceles triangle. Let's draw one isosceles triangle. Okay, this is my isosceles triangle. This is C, this is B, and this is A. Okay, this is my isosceles triangle. Now, this is 8. This is also 8. Then a circle with BC as a diameter passes through A. So there's a circle drawn where it passes through A and BC is the diameter. BC is the diameter and it passes through A. So something like this. It's not very easy to look at, but this is the diameter. This is the diameter. Okay. Also, there's one more thing given. Another triangle is drawn with center at A which passes through B and C. So let's say this is the center and it passes through B and C. So this circle is something like this. Okay. So, but this is very difficult to look at and to figure out everything, right? Right. So if I was to rotate this 90 degrees, then it would be a lot easier for me to understand this. What I'm saying is, suppose I draw my triangle like this. Okay. So what would my circle look like? The one where BC is the diameter, this. And one where A is the center will be this, which passes through B and C, this. And I have to find the area of the overlapping regions of the circle. So I have to find this area that is overlapping between both these circles. This area I have to find out. Okay, this is what I need. If I look a little closer, okay, I'll remove this. Now I know what area I have to find out, so I'll remove all that ruckus that we had created. Okay, now I know what area I have to find out, and where is this area? It's over here. Can I not see that this area is what? This particular area that I have to find out, this area is the area of this smaller circle minus this thing, this sector thing, right? Minus this sector thing. Then I'll get this area. What I'm saying is, okay, let's figure out all the measurements that have been given to us. If this is to be 8 centimeters, can I find the length of BC? Yes, I can. It will be 4 root 2. Why will it be 4 root 2? Because I know that this is a diameter. BC is a diameter. And so since BC is a diameter, this will have to be a 90-degree angle because it is an angle subtended on a semicircle, right? It is an angle subtended on a semicircle. So this will be 90 degrees. Angle A is 90 degrees. That's why this BC side will be 4 root 2. Now I have this thing. What I'm saying is, what do I have to find out is the area of this, half of the area of the smaller circle plus the area of the minor segment, right? Plus the area of the minor segment. What I'm saying is, this overlapping area is half of this smaller circle, this area, plus this thing, this segment that is being made, right? How can I find that out? First, I'll find out half of the area of the smaller circle. That will be 1 by 2 into pi 4 root 2 whole square. This is the area of the smaller circle. Now I have to find out the area of the this segment. What can I write this to be? I can say that this is the area of this sector. Area of this entire sector. This one. This sector. I'll retrace it. Okay. Follow my cursor. This sector. The area of this sector minus the area of this triangle. So I'm left with this. This is only what I have to minus from this entire thing, right? Now, sorry, what I have to add in this entire thing. Yeah. So what is the area of the sector? Area of the sector is half. 1 by 4, because pi by 360. 1 second, my marker just went off. 1 second. Yeah. So it is. Let's write the entire thing. I'll not do any shortcuts because it's a very confusing thing, right? Let's do everything. I'll not do shortcuts. So that is theta. What is theta? It is 90 upon 360 into pi. And what is r over here? R is 8, because this is the radius of the circle, right? This is the radius of the circle, and r square minus the area of this triangle. What is the area of this triangle? Area of this triangle is what? It is half into 8 into 8, right? Let's find all the values now. I have pi by 2 into, what is, say it is 16 into 2, which is 32, right? Plus, now I have this is 1 by 4 into 64. 1 by 4 into 64 gives me 16 pi, minus 1 by 2 into 64 gives me 32. So in total, what do I have? I have 16 pi plus 16 pi minus 32, which is what? Which is 32 pi minus 32. So if I was to take 32 common, I will be left with pi minus 1. Is it there in the option? Yes, it is. So this was the answer. Okay. Let me know if there are any doubts. Quickly tell me if there are any doubts. And also go through all the questions that we've discussed today. Go through everything that we've discussed today. Let me know if there are any doubts. Okay, Raghav, thank you. Okay, Aditi. So this is how you try and tackle geometry. It can be confusing a little bit of times. Okay, but the key is visualizing what is being said in the question. The second you visualize it, your question is solved. Okay, so it is what you have to practice in geometry is to visualize everything. That's it. Because there are only a little bit of formulas. And you don't have to use a lot of concept like you have to use in arithmetic or algebra, right? You just have to know a little bit of formulas and visualize. That's it. The second you draw a good enough diagram, your question is solved. Okay. Okay, guys. Thank you for joining. I'll stay back for a little while if you have any doubts. Otherwise, we'll end the session today. Thank you so much for coming. Good night.